This video is to prove inverse function. As we know, if two functions are inverse functions, they have to satisfy these two equations. Therefore, we got to use these two equations to prove those two functions are inverse function or not. In this video, I just use one of these. Then you will get some clue how to use the other one to prove. Show that f of inverse of f of x equals x. We already figured out for fx equals 2x to the power minus 6, inverse function is a cubic root of x plus 6 over 2. We want to prove these two are inverse function. We got to use this equation. So this equation on the left side, that is a composite function. We have f of f inverse of x. That means we got to do insider first and then go to outsider, that is f function. So we got to use two steps. First step, do the inverse of fx, that is a cubic root of x plus 6 over 2. Then we go to second step, that is f of. We know whatever you got for the insider, let's go to this parentheses. So we got the cubic root of x plus 6 over 2 equals. For f of cubic root of x plus 6 over 2 means every single x in f function. So we go to f function here. You got to change into cubic root of x plus 6 over 2. So we plug in 2 times cubic root of x plus 6 over 2 third power minus 6. Cubic root and then do the third power is gone. You could say it's cancelled. So we got the 2 times x plus 6 over 2 minus 6. Then reduce. We got the x plus 6 minus 6. That is equals to x. So we finish the proof now. We did f of inverse of f of x equals x. Now for f, we got the f of x equals this. We figure out inverse function is this one. We want to show that this is true. Still, first step, we got to get the inverse function of fx. That is a 3x minus 2, 4x plus 1. That's the first step. Second step, then we go to f of something here. This value go here. So we got the 3x minus 2, 4x plus 1 equals. That means for every single x in f function, this is x, here's x, you got to change into 3x minus 2 over 4x plus 1. So we got 3x minus 2, 4x plus 1. Here is a plus 2, so we have to write down plus 2. Then 3 minus 4 times 3x minus 2 over 4x plus 1. how you work this out? We have denominator 4x plus 1. So we got to do every term multiplied by 4x plus 1. 4x plus 1. Here, 4x plus 1. And multiplied by 4x plus 1. Then reduce. This is gone. This one you have to do distributive property. This you have to do distributive property. This is gone. Then negative 4 you have to do distributive property. Therefore, we got 3x minus 2. Distributive property and plus 8x plus 2. Look at the denominator. 3 times 4x, that's 12x. 1 times 3, that's plus 3. Then we go to negative 4, do the distributive property. Negative 4 times 3x, that's minus 12x. Then negative 4 times negative 2 is plus 8. Then cancel. Minus 2 plus 2. Positive 12x, negative 12x. You got 11x over 11. So equals x. We finish proving now. Now we show that this is true for these two inverse functions. When you're working on composite function, remember insider first. So we got to do inverse function first, then go to original function. Inverse function, that we got negative 1 over 5 natural log of x minus 7 over 2. Then we go to f of something. This one go into here. That we got negative 1 over 5 natural log of x minus 7 over 2. Now, every single x in f function, you have to change into negative 1 over 5 natural log of x minus 7 over 2. So this x, you have to change into that. So we got 2 times e negative 5. Then put the negative 1 over 5 natural log x minus 7 over 2. Then plus 7. We simplify. Negative negative is a positive. 5 is gone. So we got e natural log x minus 7 over 2. Then plus 7. According to the rule of logarithm, if these two bases equal to each other, we got this k. For natural log, base is e. Therefore, cancel out this one. We got 2 times x minus 7 over 2 plus 7. Then reduce. We got the x minus 7 plus 7. Therefore, equals x.